the typical workflow in here is once you import or open up a file, you want to make sure that this is in the intended units that you want to machine it from. So by default, I had my workspace set to inches. So it automatically, loaded the STL file in inch units, because STL files typically do not carry a units. It'll just open up in whatever workspace units you have set to. So if you go into analyze and click on part information, it gives you the length, width, and the height in here. So by looking at these dimensions, it tells me that this probably should be in millimeter units, because the numbers appear to be way too large for an inch.
Yep.
Right? So there's a couple of ways how you can scale it. One of the ways is you can switch from inches to millimeters and back to inches, or the simplest way is you just select the model in here, go to transform, and you can pick scale, and then you can specify the scaling factor in here. You can say select the scale factor. You can put in 1 divided by 25.4. So you can do the math in here. That would be 0.03937, right?
Yep.
So I can put in 0.03937. That'll scale it to, scale the model. Or the other option is you can just click on units here. It'll ask, do you want to switch from inch to millimeters? I don't want to scale it up again. I pick no to it. So now the units are all in millimeters. I can click on it again, and you can see it'll automatically scale it by 0.0393701. And now the model units is in, inches. Now if I go up to analyze and select part information, it'll give you the overall length, width, and the height for the model based on the current orientation of the part. Now, to mill this part on your CNC router, you probably have to place it on like a side this way right here, and your router can hold this part. Your chuck could be either on one of the ends, and you can machine this part. So you need to orient it. So this would be along the axis of rotation.
Yeah.
Now, is your rotational axis set on the X or the Y, parallel to X or Y on your equipment, CNC equipment?
I think it's on the Y.
On the Y? Okay. Okay. X. Okay, not a problem. So we can rotate the part. So one of the ways I would do for orienting the part is I can select the part in here, and there's different ways I can use this graphical manipulator in here, where I can have it rotate. I can say I want to rotate it about the 90 degrees on the Y-axis first, right there.
Yeah.
And then I can take this part in here and rotate it by either 90 degrees or minus 90 degrees or 270 degrees on, so basic on the Y. So you can see now it's oriented, the part is oriented along the Y. And then I can go through the process of placing it at the origin at a later step. So the first step is here, I want to define my machining process. Under the program tab, we would want to select the definition to be manual and pick 4-axis. Specify the configuration as table, as you have a rotary chuck, which would be rotating your workpiece. And then you specify the rotation axis to be X or Y, depending on how it is established or set up on your machine tool. And then you pick OK to accept it. So your machine is now defined as 4-axis. The next step is you can make a selection for your post processor in here. Now, as I mentioned, we have a post for all the different Laguna machine tool series. And you can select the post from the list in here, and we have all of these posts available to you.
This conference will now be recorded.
Okay, so as I was referring about the post processors in here, we have posts developed for a wide range of machine tools, and we have posts for all of the different Laguna series. So it could be a CNC, you could be running the Smart Shop with the BNR.
It's the Swift series model.
Okay, it's a Swift. So we have the Swift in here. We also have the BNR IQ. So you can select the series right here, the Swift. And then you can specify your output file extension. Could be NC, or Laguna likes to use PRG for their programs. And you can select the PRG from the list, or you can add a new file and enter it in as .prg for program, or you can use .nc as well.
Okay. Yeah, I would say it's an NC. Yeah.
Okay. All right. Now the next step is you want to go ahead and make sure that the orientation is correct. So as you take a look at the part, looking down from the top view, you want to make sure the part
Yeah.
is in the correct orientation. So this is on the Y, but the origin is over here and the part is here. So we'll work on how to get the part aligned to the origin. So there's a couple of ways you can do it. You can either define the stock first and then move the part to the origin, or if you prefer to move the part first to the origin, you can use align set wall coordinates. You can pick set to part. I can choose south, and then I can put it right in the center or the mid Z right over here. So if you take a look at the part, it's basically putting the origin over here. But if you want to move it to the pick a point in the center of this, like the leg over here, we can move it down as well. So we can select this and here. Now we can further adjust it so we can position it that's in the center. Now, would you be starting with like a rectangular blank for machining this part?
Is it rectangular or is it cylinder? Cylinder. Cylinder.
A cylinder, okay. And what would be the diameter of the cylinder that you plan to use typically? Is there a pre-cut size of blank?
12 inches.
12 inches, okay. So let's define our stock in here. We'll create a cylinder stock. And if you notice it automatically determines the minimum stock size you would need to be able to account for this. So it says the radius is about 4.5, which is about 9 inches in diameter. So if you said it was 10 inches or 12 inches in diameter?
12.
12. So that would be 6. And then the overall length, you can specify it right in here. So you can put in the total length. Now, as long as the length is larger than the overall length of the piece, you should be okay. And we can, you need enough room to have it, fastened or fixtured in your chuck. And then you can also give it a length. So I can, for example, I could say 15 inches, right?
Okay.
So that creates your stock, the workpiece, which is a cylindrical blank. And as you see right there.
Yeah.
And now you can also have the, sorry, go ahead.
Are we able to save that as a template, the stock?
The stock, you can save this information with your file and you can import new parts into it. You can do that. So, we typically do not save the stock information, to a template. We save the knowledge base, which saves the workflow of operations knowledge base. One of the ways you could define a stock blank is you can, in our pro configuration, you can do what is called a stock from selection. So you can actually have the stock imported along with the part, and you can just highlight the stock and do a stock by selection. That's something you can do. If you do not want it to just enter in the stock, radius and the length. Okay. So now the next step we want to do here is align it. So we can use align stock, and you'll notice that you can have it aligned in the center. And center. You can choose which way you want to put it to the north, so you have more room here on the back of it, or you can have it put in the center, or you can choose which side. So if the chuck is going to be over here and you want to leave just a minimal amount of material on the front, you can align it to the north, which is basically the face over here. And then you can also take this part and then just nudge it down a little bit. I can say I want to bring it down maybe by like 1/4 of an inch, right, from the edge. So just give it a little bit clearance over there. Okay, so now if I hit save to save this work in here, it automatically saves all of this information to our file. So it automatically saves the entire workflow that we put into a file. Now the next step is to program some toolpaths in here, and you would typically want to do like a roughing operation and then go into a finishing operation. Is that correct?
Yeah, I would say so. Just get rid of a lot of that excess stock.
Okay. And what type of material do you typically machine these with?
It's going to be like a polyurethane foam. So that's a PU foam.
Okay. So we have a material library in here. You can select it, or you can also add your own material types. I do not see one for the foam, but you can add it to the list. And you can also pick something that's close enough to that. You can do like an acrylic or wood or nylon, and polycarbonate, right? So I can select that. And we could then also specify, tools. We can define the tools and the library of tools we can be created. So based on the typical tool types that you use, so you might want to use like an end mill for your roughing process, maybe a ball mill for the finishing, or if you just want to use one tool for all, you could do that as well.
Yep.
Okay. All right. So, and then you can specify your feeds and speeds, and based on the material, our CAM system will be able to help you establish feeds and speeds. Or if you want to go with the feeds and speeds that you are already familiar with, you can enter those in and then save these tools to a library as well.
Okay.
Okay, now the next step before we start programming this part, we want to make sure that we are establishing your XYZ origin, so you can do a touch off and then establish the rotation center correctly in here. Now, where would you like to place the origin on this blank in here? Would you want to put it right in the center line of the stock and then put it to the rightmost face or to the leftmost face in here? Or you want to put it the 0 to the top in here?
Yeah, I would probably say center. Center.
Okay, center and center, or center and the rightmost face?
I say center, yeah. I say center and center, yeah.
Okay, so what you do is here, go into align, pick set world. You can say put the 0 to the stock, center and center. So your 0, 0 will be right in the center of the block as you see it right there.
Yeah.
Okay?
Yeah.
So you can put it right in the center and then you accept it. So there's the 0, 0, 0 place right there. Now, if you want to rotate this part, you can do that. If you need to rotate it, you can always rotate the part as well. So right now we put the 0, 0 right in the dead center in Z as well as in X and Y. Okay?
Yeah.
Now, typically, you would want to rough it out with like a roughing from multiple different orientations, like maybe from the top and from the bottom, or you can do additional sides. And you can also contain the toolpath to specific areas. To contain it, the simplest way I could do it is just put in like throw in a boundary in here. I could say this is the boundary and this is how far I want it to cut. You can just place a boundary in here, okay? So that I don't want to cut in the back of it. And I'm going to go in and select a roughing strategy here. We'll pick a roughing as 3 axis. We'll pick roughing. This is horizontal roughing. I'm going to just pick this as the area to contain the roughing toolpath, so we don't want to cut past it. We can select a tool, so you could use like a 1/2 inch end mill or a 3/4 end mill, or you could even just do a ball mill for it. You specify your feeds and speeds, automatically loaded from the tool. Your clearance is automatically established based on the part and the stock that you created. You can now establish your cutting conditions. You can choose whether you want to do a cavity cut pattern or a facing pattern. If you just wanted to go linear cuts back and forth, you can use linear and have it go parallel to the y-axis. You can specify that right in here. You can use a linear cutting pattern. You can specify your step overs in here. And you can also specify how far down you want to cut in a Z. You could say you only want to go halfway through. So you can pick a point right in here and say we only want to go right up to 0, or maybe slightly past it. You get a nice little overlap on it. And you can choose how much of material you want to take down per cut. That would be your step down, and then you pick generate. So in this particular step, we are creating like a linear cutting pattern, just going back and forth. And you can see that it automatically takes into account the stock that you define. So it knows that the stock is a cylinder. So you can see that it's not cutting air and it's only removing where there's material. So in this particular step, we are doing a roughing in levels. I just chose a linear or lace cut pattern. So we have other cut pattern types as well. So in this particular step, you're roughing it down in levels. And you can also change the step over, step downs. You can change these parameters in here. I could say I want to go 70%. I could probably even take a deeper pass, like 100% of the diameter of the cutter. So you can do it in much, since the material what you're cutting is not very hard, you can do it in multiple steps. And you can always do a pause and pick simulate to end. It'll run through the simulation. In this particular step, you'll also notice that there's a holder collision that was identified in here with the stock. Since the tool is not long enough, the holder is cutting in as you're going down in the sides.
Okay.
All right. So you can either use a longer tool or stop it short so you don't have to cut all the way through. We can do it from 4 sides if necessary. So I'm just going to do it from 2 sides here. And now I'm going to add a new setup called a rotate table setup. So in this particular step, we'll rotate the table, or the rotary axis will turn the blank by 180 degrees. You can see going from the top down to the bottom. So on your equipment, CNC equipment, the stock would be rotated.
Yeah.
We'll now repeat the same operation. I'm going to do a copy and a paste in here, and then right-click and regenerate. So in this particular step, it's going to compute the toolpath from the other side. You can always speed up the simulation in here to tell it how fast or slow you want it to run. And you can always do a pause and then pick simulate to end.
Yeah.
Okay.
Okay.
So right now we have it roughed from the 2 sides.
It's recordable. Cut it faster. Yeah. Okay.
All right. Okay. Now we want to go back and do some finishing operations in here. We could do similar to what we did here. We can do a finishing using 3 axes. While we're already on the setup here, I can go to a parallel finishing operation in here. Pick a tool for it. Maybe go with a ball mill. You can specify the tool, be a 1/2 inch or 1/4 inch, whatever size cutter you want to use. And then you can specify your cutting conditions in here. You can specify your step overs. Again, the Z containment, we can say we don't want to go past, maybe slightly past the center line of the part right here, right?
Yep.
And we can also control the entry and exit. We can specify the clearance. We can also do a skim clearance in here as a transfer, and then we pick generate. So there's your 3-axis finishing cut pattern. So this is doing, what we are doing right now is all indexed machining. So you'll notice that it's basically, the stock is rotated and stays at that orientation while you're cutting it, right? And now we can go back and rotate it back to 0, and then I'm going to repeat the same operation again from the other side, and then generate it. So right now we are running a simulation once we rotate it over to the other side.
Out of curiosity, what was the simulated time on that?
Okay, you want to find out what would be the run time? Okay, how long it would take to cut it? Okay, so this all depends on what we put in for the feeds and speeds in here. So if I right-click on the machining job, we'll take a look at what we put in for the feeds and speeds, and let's go to information. So here I chose 40 inches per minute for roughing, which is probably way too slow for the material cutting. So it says that the roughing operation would take about 2 hours to rough it if you're only cutting it 40 inches per minute. So we can optimize it to maybe bring it down to just a few minutes. And then the finishing operations were just like about 15 minutes each. So we can go back and update the settings in here. So what I would do here is go back and change these, and automatically it'll update the feeds and speeds. So I can go to the roughing operation. I can change the feeds and speeds on the tool in here. I can say the tool cutter I'm using is a carbide cutter. I could say I want to go at 20,000 RPM, the spindle, and the cut feed rate for roughing, I could say I want to go at like maybe 200 inches per minute. Okay, so when I make the change, it automatically updates it in these operations. I could do a similar, cutting feed rate for the finishing as well. I can put in, same 20,000 RPM, or you can even go faster. You can say 200 inches per minute, cut feed rate, save the edits on the tool. Now let's go back and take a look at the machining time. So you'll notice that it's under, about 20, a little over 20 minutes for roughing from each side, and then the finishing.
With those parameters you put in. This is the step overs, right? So the tighter the step over, the smoother what do we have as our step over?
Yeah, I only had the step over for finishing at 25%. I could, you know, drop it to like 10% or even 5%, depending on, you know, how fine of a finish you want to accomplish. So now if you take a look at the time, you'll see that the finishing is only from the two sides takes about 15 minutes.
Still 30 minutes.
Okay, so there's one thing I would like to point out in here is, you know, if you'd like to do a continuous finishing where the part is rotating as you're cutting it, then we need to make sure that the entire part is through the rotation center. In this particular case, it would be off center because this is your stock blank in here, right? So after you complete the roughing operation, and if you recenter it, so what I meant to say is if I take this part in here and I'm going to use the graphical manipulator in here, and if I actually move the part so it's right on the rotation center, you see what I'm doing right here? So I'm putting the part kind of on the center of rotation. So if I do this step here, so if you refixture it or reorient it after you're through with the roughing operation, you could use a continuous 4-axis finishing operation in here. And I'm going to show that.
Gotcha. Okay.
Yeah, so in order to do a continuous 4-axis finishing, let me go back and use a parallel finishing in here for the continuous finishing. And you can specify the high and the low limits in here. And I can specify how I want to go along axis. I could do across, or I can even do like a helical cut pattern.
Okay.
And I can specify the step over in here. I'll just go with 20%. And over here, I can also set it to not to go below ½ inch radius.
Okay.
So now when I generate this toolpath, this will produce a continuous toolpath, a continuous finishing toolpath. So in order for you to do a 4-axis parallel finishing or one of the continuous 4-axis toolpaths, you need to make sure that the, you know, if you have features that are dipping below the rotation center, you wouldn't be able to cut to it. So you would have to basically, you know, reorient the part or reposition it so that it is through the rotation center. Unless you want to break this up into 2 sections in here and do this section with the continuous and then the rest with the index operation.
Yeah, got a question for you. Assuming we got all the parameters set up, how long time-wise would you say it would take to generate a G code?
The G code generation is instantaneous, so I can take these setups in here. For example, I have these 3 setups right here. I just select these 3, right-click and post, and I'll specify a folder. I'm going to call it, give it a name. I'm going to call it test1.
Yep.
And the G code will be generated and displayed to you in a text editor, which could be like a notepad, or any CNC editor that you pick. There's your G code, which is now ready to be sent out to the machine.
So probably 5 minutes to generate your G code from the time you pull in an FTL?
I would say, yeah, you can also, you know, optimize your workflow here. You can save all of these to a knowledge base. So when you have similar parts, other parts that you want to machine, you bring in the part, you orient it, you define your stock, and then you load the knowledge base and generate the toolpaths for it. So it's going to be, you know, less than a few minutes to do it.
Yeah. Okay.
Because the knowledge base allows you to save the workflow, like these roughing operations, these rotate table setups, the finishing operations that we just did, all into a you know, a template that you asked about earlier. So with the parameters, the feeds and speeds, your step overs, all of that information gets saved. The only thing that's going to be different is the geometry that you're going to be, you know, specifying for it to be programmed. And maybe the length of the stock could be slightly different based on the scans that you bring in, right? And not all the scans are going to be the same size. So you may have to just recreate the stock and then, you know, since we're using a boundary here, you can also modify the boundary in here for the containment.
Yeah. Okay.
So what we did so far was the indexed operation. Right now, what we are generating is the simultaneous or the continuous 4-axis operation. So it is computing like a helical cut pattern, and I had to reposition or reorient the part so that the part is on the rotation center. The entire part flows to the rotation center in here.
So, question for you. So, and I'll probably see it in a second once I finish generating the G code. Is it one file that will take care of the roughing, the parallel finishing, and all that, or are they individual files?
Well, what we did here was just a finishing operation. What I did here. So if you notice, this is a continuous finishing operation. Let me run a verification in here without the stock, with just the part being displayed, so you'll see it. So you'll notice that on the machine, the part would be rotating.
Yeah.
And it's doing a helical cut pattern where it's stepping it over. So it's a finishing operation. Now, if you wanted to take the stock dimension into account, or the cylinder stock into account for the roughing, the horizontal roughing using the indexed method would be the best way to go about it.
Okay.
And also here, you notice that we had to reposition the part in order to make sure that it is on the center of rotation, because it's the part is asymmetrical in here, right?
Yep.
Okay. Do you have any other questions I can help you here?
No, I think it looks very user friendly, and you know we're really doing the same thing day in day out. So I think once we establish our templates and feeds, the only thing that's going to change is the cylinder length.
Mm-hmm.
Right.
So yeah. So here's what I was referring to as. If I go back and load this part in here, you will notice that the entire workflow is saved. So I can save these to a knowledge base. Okay. And I can pick a folder where this needs to be saved. I can put it under your folder or your desktop or wherever you want to save it. So I can save it over here. And then when you bring in a different part, let's say we want to start out with a new file in here. So I'm going to select File and New. And you want to bring in an STL file, I'm going to just load this part in here, right? So in your CAD system, if you can figure out a way that would be easily reoriented, you don't have to go through the steps in here. So I'm going to do a rotation of 90 degrees here, and I'm going to select this part, rotate it on the Z by minus 90 degrees to orient it, and then I can basically go back and put the origin where I want to put it in here, right?
Yep.
And then I can redo the stock in here. I could do a cylinder stock. Now, if you had modeled a stock, I can specify the stock, and then I can align the stock to the part.